Hello everybody, myself Kiran from Sri Venkateswara College of Engineering, Bengaluru. Today, the topic of my presentation is all about corrosion and its types. Corrosion. Corrosion can be defined as the destruction or loss of metals or alloys by surrounding environment through chemical or electrochemical reactions. Example, rusting of iron. This is a picture of rusting of iron. Types of corrosion. There are two types of corrosion. One, differential metal corrosion. Second one is differential aeration corrosion. Differential metal corrosion. Differential metal corrosion occurs when two dissimilar metals are in contact with each other and exposed to a corrosive conducting medium. The metal with lower electrode potential acts as anode, undergoes oxidation and gets corroded, and the other metal with higher electrode potential act as cathode, undergo reduction and protected from corrosion. This type of corrosion is known as galvanic corrosion or differential metal corrosion. The rate of corrosion depends mainly on the difference in potential between two metals. Higher the difference, faster is the rate of corrosion. The reactions may be represented as at anode oxidation takes place, then metal undergo oxidation, then gives metal ion and electron. At cathode reduction takes place, then hydrogen ion reduced to hydrogen. Example for the metal corrosion are when iron is in contact with copper of 0.34 volt electrode potential and iron has minus 0.44 volt of electrode potential, then iron becomes anodic and undergoes corrosion, whereas copper becomes cathodic and remains unaffected. Tin coating copper vessel, steel pipe connected to copper plumbing, bolt and nut made up of different metals. These are the examples of differential metal corrosion. Here there is a picture of bolt and washer. Here washer get corroded but bolt doesn't get corrosion because washer is made up of iron and bolt is made up of steel. Washer has lower electrode potential but bolt has higher electrode potential. So iron gets corroded. Next is differential aeration corrosion. When a metal is exposed to a different concentration of air or oxygen, part of the metal exposed to a lower concentration of oxygen becomes anodic and undergo corrosion, whereas other part of the metal exposed to higher concentration of oxygen become cathodic and remains unaffected. This kind of corrosion is called as differential aeration corrosion. Example, when an iron rod is partially immersed in NaCl solution, part of material immersed in a solution is exposed to a lower concentration of oxygen, become anodic and undergo corrosion, whereas part of outside NaCl solution is exposed to a more oxygen, become cathodic and remains unaffected. Here, when a rod is immersed in a NaCl solution, there is a less concentration of oxygen, so there will be an act of oxidation takes place. Then metal get corroded inside the NaCl solution, but outside the NaCl solution, there is a rod because there is no corrosion due to the more oxygen presence in our surroundings. Anodic and cathodic reactions are At anode, metal oxidize and give a metal ion and electron. At cathode, water combine with oxygen and gives hydroxides. Net reaction is when iron metal reacts with a hydroxide gives a metal oxide. Example: part of nail inside the wall undergo corrosion. When dust particles hit on metal bar, the part under the dust undergo corrosion. Partially filled iron tank undergo corrosion inside water. Typical example of differential aeration corrosion are the waterline corrosion and pitting corrosion. There are some pictures of waterline corrosion and pitting corrosion. Here, first one is the waterline corrosion. In the bowl, there is a formation of rim shape corrosion because due to the waterline corrosion. Here, next one is pitting corrosion. When dust particles are sit on a metal, there is a formation of rust in that particular place of a iron. Then it will get corroded and the metal will get destroyed. Thank you for watching this video.